in the video, and you guys will do this some more on some of the different engines. So we're going to remove our timing chain, timing gears, timing belt, whatever we have for our drive mechanism. We're going to have to remove basically all of our other valve train components. So rocker arms and push rods, lifters, that's all for doing with the overhead valve. And that's because those lifters will sit down on the lobes, and you can see the lobes are smaller than the cam bearing journals. So if we leave the lifters in, the cam can't pull out. So we have to get the lifters out first, then the cam can actually be removed from the lobe. Also, like we showed in the video, push rods, rocker arms, all of our valve train components we want to keep in the proper order. So if we're planning on reusing any of that stuff, it needs to go back in the same spot. If this is an overhead cam engine, we've got some different designs. So again, a lot of our overhead cam engines, the cam actually bolts in from the top. Some of them, the cam will slide out the end. So we've got a lot of different variations. In that case, sometimes the cam will come out first, sometimes the cam will come out last. So we really got to look at our procedures and see how that particular cylinder head is designed. All right, measurements. I'm going to go over just a couple quick things with you guys on this. For measurements, the main thing we're checking for is to see if our cam bearing journals or our lobes are worn. So we can measure our cam bearing journals, see if they're the proper size. On the lobes, we talked about some ways to measure the lobes. This is one of those areas where we might be able to do a lot, we might be very limited. So this camshaft, I can do a whole bunch of different measurements on this. But if I don't have any specifications for this cam, do those numbers really mean anything? No, because they've got nothing to compare it to, right? Some manufacturers will give you every spec in the world you want for this cam. So you can do all those measurements, you can inspect it really good. Some manufacturers will give you almost no measurements for this. So here's kind of the basic rule when it comes to measuring a cam. If it's the flat tappet design, what am I going to do with this? Throw it away or replace the whole thing, right? So I'm probably not going to bother doing any measurements, unless I really, really think it might be reusable. If it's the roller design, how much wear and tear do we get on this normally? Almost none, right? So I might use some measurements, but really what I'm going to do is a good visual inspection. I'm going to look at the lobes very carefully for any signs of damage. I'm going to look at the roller wheels and the lifters for any signs of damage. If everything looks really good and there's nothing I can catch my fingernail on, I can reuse this stuff, right? If I see any physical damage or there's anything I can catch my fingernail on, guess what I'm going to do? Throw it away or replace it. So in general, we don't do a whole lot of measurements for camshafts. It really comes down to what style is it, and then visual inspection. So camshaft selection, we talked about this as well. Normally we're going to use just a factory replacement. For performance, we can change the cam. That's another area where if you guys are interested in a little bit more information on that, talk to me, and I can give you a little bit more info, but I don't want to waste your guys' time with a lot of info on cam design and cam specs, because for most of you it's not something we're really going to use much. So the last thing we have is variable valve timing. So let's talk just kind of real briefly about variable valve timing. Normally we have our camshaft and it has its lobe design built into it, right? So we have a certain amount of lift, a certain amount of duration, a certain amount of lobe separation angle designed into this cam. That's always sort of a compromise. So for a normal street vehicle, we want to have good low end torque, so good power, basically offline, get that heavy vehicle moving. We want to have decent performance at higher RPM, but really more important, we need good fuel economy and good emissions, right? Well, our camshaft design is always going to be a compromise between those different things. So we can have a cam that makes really good power, but guess what's going to happen to fuel economy and emissions? They're going to suffer, right? So we got to sort of make a choice. With variable valve timing or variable camshaft timing, we're going to get rid of a lot of that compromise. So we can basically change the valve duration, how long the valves stay open, or when they open and close, sort of on the fly. So instead of having just one camshaft design, we have almost infinite different camshaft designs built into our engine through variable valve timing. So this is something that's become almost standard on almost all of our new engines. because it allows our engine to make more power throughout the entire power band or RPM range and get better fuel economy and better emissions as well. So this chart shows you some examples of what we might do to valve timing based on our driving conditions. So in some cases we're going to retard the valve timing, basically make the valves open and close a little bit later. In other cases we'll advance the valve timing, make the valves open and close a little bit sooner. And again, that's going to sort of change when our engine makes power. And so based on our driver demand, we can make those changes. So here's sort of the common way that we operate variable valve timing. Typically, most of this happens inside of our camshaft sprocket. So our cam connects to our timing belt or our timing chain. And this whole assembly is what we call a camshaft phaser. So instead of being a solid sprocket, there's actually some movable parts and pieces inside here. This center hub is actually attached to the cam. Outer sprocket is attached to our belt or our chain. And then in between here, we have oil. That oil is controlled by a solenoid that's controlled by the computer. So what we do is we basically put oil on one side of these vanes or on the other. And that will actually shift that sprocket on the cam. So we're basically turning the cam a little bit relative to the timing belt or timing chain. So we're changing that timing a little bit, and we can do that on the fly. So the computer's controlling that adjustment all the time. So sometimes they call this variable valve timing. Really, more properly, we should call it variable camshaft timing. Because we're really changing the timing of the camshaft itself. On engines where we do this could be a bunch of different engines. So this could be overhead valve, we could do this, where we have just a single cam. If we have single overhead cam, we could do this on each cam, on each cylinder head. If we have a dual overhead cam engine, we could do this on both cams like we see here. We could operate just the intake cam that way and the exhaust is just a normal cam, or vice versa. So there's a lot of different variations in terms of variable cam or variable valve timing systems. So one example, Toyota, they use the term VVTI, variable valve timing. I is for intake. So in those engines, they only control the intake cam. The exhaust cam is just normal. So this one's just a little bit different, but this is basically that solenoid that's actually going to control flow to that cam phaser. And this chart's in your book. This shows you basically some of the benefits of changing exhaust cam phasing versus intake cam. So what we can do with that, so exhaust, you notice, has a bigger impact on emissions and fuel economy. Intake has a bigger impact on performance. So ideally, wouldn't it be nice to be able to do both? So that's